Okay, so as I mentioned, logarithms are exponents. Pull that out. Okay, represent exponents. They are used to solve exponential equations. And our first task today, is this you?
Yeah, it's broken though.
Oh, trash.
Yeah, it's just on top.
Our first objective here today is just to be able to evaluate logarithms. Refresh your memory on evaluating logarithms. So if you would see this, evaluate log to the base 3 of 27. All that is asking you is what exponent would this 3 need? So what base would what exponent would my base of 3 have to have in order for it to equal 27? So this is kind of your thought process. 3, my base, raised to what power equals 27? And in this case our answer would be 3, because 3 times 3 times 3 is 27. Okay? So when you see this, what you're trying to find is you're trying to find the exponent the base would need in order for it to equal this number right here. That's how you evaluate logarithms. So with that in mind, we're going to do something. Log to the base 4 of 16. What would that answer be?
4.
Nope.
2.
2, because?
4 times
4 times 4 is 16.
Ouch.
Okay? Or if I'm thinking of it with exponents, I could think of it as, I know 4 times 4 is 16, but explain it to me in exponents.
4 squared is 16.
Because 4 to the second power is equal to 16. That's why the answer to this is 2.
So the bottom number that's smaller is the base number.
This is always your base. Yep.
Is there always going to be one of those?
Not always, but if you don't see one, it's either a 10 or an E, which I'll get to.
Okay.
Okay? Log to the base 2 of 16. Log to the base 2 of 16.
To the third.
Maybe 4, right?
Would be 4.
Yep. 2 times 2 is 4 times 2 is 8 times another 2 would be 16. 2 to the 4th power is 16. So the answer to this would be 4, and the reason that's true is because 2 to the 4th power equals 16.
I skipped one.
Okay? Log to the base 6 of 1. Log to the base 6 of 1.
Would it be like a negative exponent or something?
Nope.
Or a 0?
No. 0.
0?
And then name the 0th power is 1.
Because anything with a 0th
Yeah.
power is 1. Very good. This answer would be 0, again, because 6 to the 0th power equals 1. Or really anything to the 0th power is equal to 1. So anytime you see a 1 right here, okay, log of any base of 1, it will be 0.
Unless the base is 1.
Right?
Then it would just be 1.
At the base is 1, it could be any answer really, right?
That's true.
Because 1 raised to any power would
Is
be
1.
1. Yep. Okay. Log to the base 4 of 1/16. Log to the base 4 of 1/16.
-2.
It is -2. Okay? Because 4 to the -2 power is really equal to 1 over 4 squared, or 1/16. So this answer would be -2, again because 4 to the -2 power is 1/16. Okay? Log to the base 9 of 3. Log to the base 9 of 3.
Would that be 1/2?
Be a third.
1/3?
It's one of those.
1/3.
It's It's a third because 3.
No,
Am I right?
it's
I'm not right.
Wouldn't it be 1/2? Because 3 squared is 9. So isn't that just like the opposite of it or whatever? Yeah.
Yeah.
Just
Okay.
a flip.
That's
Raising something to the 1/2 power is like doing what?
Like square rooting.
Square rooting it, right?
oh, okay.
Yeah.
What's the square root of 9?
3.
3. Okay. Answer to this is 1/2. Because 9 to the 1/2 power does equal 3, because the square root of 9 is equal to 3. Okay? It's because 9 to the 1/2 power equals 3. Okay? So I just did a few new ones with you guys. This was from the other class. Looks like I did one similar here. I actually did that problem with you. I didn't do 32, but 2 to the 5th is 32. Same idea. I did a similar one here. Here's your negative. I did the same one, it looks like, with you guys there. So again, these are just more of some of them that I had done already with 4th period today. Here you go, there's a couple other ones. Log to the base 5 of 1/25. Okay? That'd be another negative, right? Because 5 to the positive 2 power is 25. So 5 to the negative 2 power would be 1/25. Okay? Here's an answer that's a third though. Log to the base 8 of 2. That would be 1/3. Why?
Because 2 times 2 is 4 times 2. Well, 2 to the third.
2 to the third is 8. So 8 to the 1/3 would be 2. Raising something to the 1/3 power is like doing what type of root?
Third. That's 3. Right?
Cube root.
Yeah, that.
Okay? Okay? This would be a cube root. The cube root of 8 is 2. And then the last one, I kind of did a pretty tricky one here. Log to the base 81 of 1/9 equals negative 1/2. Do you follow that one? Log to the base 81 of
It's gonna be
1/9.
like 1 over the square root of 81.
Okay? Mm-hmm.
And then the square root of 81 is 9.
Yep. So, what's 81 to the 1/2 power? What's 81 to the 1/2 power?
9.
9. Okay, well, if you want it to equal a 1/9, you just make the power become a negative 1/2 power to move it to the denominator. Okay. Another thought process on this one, if you can't read it right away, let's just try guessing and checking. What's 81 to the 1st power?
81.
81.
So the answer of 1 is too big, right? An answer of 1 would be too big, because 81 to the 1st power is 81, clearly too big. I want it to equal 1/9. Let me make the number a little smaller. What's 81 to the 0th power? 1, still too big. What's 81 to the negative 1 power?
Negative. No, 1 over 81.
1/81. Now that's too small. So an answer of 0 was too big, an answer of negative 1 was too small, so my answer's got to be somewhere between 0 and negative 1. Okay, and then you can kind of at least go through a little bit of process of elimination and come up with an answer of negative 1/2.
Oh, so negative 1.
Okay? So, evaluating logarithms, yes, no. What questions do you have? Okay. When you don't see a base, it is a base of 10. That is called a common logarithm. Your calculators usually work in common logarithms, base 10. So when you don't see a base there, just know that it does have a base of 10. So the log of 100 would be asking you, 10 raised to what power equals 100? Answer, obviously, 2. Okay? So make note of that. When you don't see a base there, guys, it definitely has a base of 10. If you see ln, that is called a natural logarithm. You have done those before as well. When you see a natural logarithm, there is a base. It is the number e. E is your base. So when you see ln, it's like saying a base of e. So what's the natural log of e going to equal? Well, think. E raised to what power equals e? 1, right? E raised to the 1st power would equal e. Or again, the natural log of 1 would also be 0. Because why?
10 to the first, or 10 to the 0th power is 1.
Not 10.
What?
E.
Not 10.
E.
E to the 0th power equals 1. Okay? So, what if I just gave you one of these equations and said explain why it's true? Could you do it?
Yeah.
Okay, what would you say? Sarah, why is this true?
Because
Because
e to the first power is 0 because anything.
Careful.
E to the 0th is 1 power, or
Or
E to
yeah,
the 0th power
yeah,
is 1.
E to the 0 is 1 because anything to the 0 is 1.
Okay, very good. Somebody explain this one. Why is this true? Why is the natural log of E equal to 1?
Because to get the same number, you have to just raise it to the first power.
Okay, so could you give me the...
E to the first power is E.
Yeah, because E to the first power is E. Can somebody explain this one? Somebody else. Why is this true? Go for it, Ryan.
Because it's like, it's already raised, the base is 10, so 10 times 10 is 100, and like 10 squared.
Or 10 to the
10 to the,
second power would equal your 100. Yeah, good. Okay? So that was evaluating logarithms. Okay? What about this right here? Log to the base 4 of 27. You may want to write this out. Log to the base 4 of 27. What's that answer? Well, that one doesn't seem quite so nice, right? 4 to the second power is 16. Not big enough. 4 to the third power is 64. Too big. Right? So I know my answer's got to be somewhere between 2 and 3, but I don't know exactly what that power is going to be. It's somewhere between 2 and 3, I don't know what it is. Okay? So, some calculators you're able to type in the base, which is great. Alright, but I want to show you the change of base formula. Just refresh your memory on it. We'll go through why it works probably later on. Alright? But if you see log to the base b of a, and you're not able to do it in your head, alright? Using your calculator, you can just take the common logarithm of this value here, so the common logarithm of a, make sure you close your parentheses, and then divide that by the common logarithm of your base.
Just put the bottom in parentheses too.
You wouldn't have to at the end of that one, but it doesn't hurt. Okay, you just got to make sure you close off the parentheses before you hit your divided by key. Okay? So this is your change of base. Okay, you're changing them to a base of 10 to evaluate them. Alright? You may want to just make sure you know how to do this. I see Alyssa's working on it right now. Make sure you understand how to do that on your calculator that you would use. Log to the base 4 of 27 does equal about 2.377. Okay, roughly. So that's called your change of base. Any questions on that? Alright? So log of the, a lot of times people say log of the big number divided by log of the little number. Okay? Log of this value divided by the common logarithm of your base. Alright? One last thing, and then I'll give you guys the opportunity to work if there's any time left here. Alright? So, log to the base 5 of 25 equals 2. We know that because 5 to the second equals 25. Just so you're aware, guys, this is called a logarithmic form of an equation. This is called the exponential form of the equation. You have to be able to go from one back to the other. So if you know this is true, it's because that is true. If you know this is true, it's because this is true. So if I give you this, you should be able to write this. If I give you this, you should be able to write this. Just changing back and forth from logarithmic to exponential form. Okay? So that is kind of it for today as far as logarithms. Kind of a good, quick introduction. You evaluated them. We're changing forms. We talked about common logarithms, talked about natural logarithms. Okay? We do need to practice this for sure, 21 through 51 odd. We'll do that for maybe the first 10 minutes tomorrow, maybe 15. They don't take long at all. Okay? And then we'll get more into the log properties. Okay? Alrighty.